It works! In my last video, I made some improvements to my version 2 engine based on some of the suggestions you guys made in the comments. So I pretty much came to the conclusion that I had taken this engine as far as I could, and that to make any more improvements, I would have to redesign the engine from the ground up, using everything I learned from building the previous 2 engines. So here's the new engine design. I made some changes and improvements to almost every part of the engine, so let's have a little talk about it. For my previous engines, I printed the crankshaft and conrod assembly separately and connected it together using a screw. Now this was a little bit awkward to get the parts perfectly in line and to have a strong connection between the two, but for the most part, it worked fine. Until it didn't. On the last run of the V2 engine, the crankshaft snapped here and here. So I wanted to redesign the crankshaft and conrod to see if I could make it any stronger. I was scrolling through Thingiverse and I saw these print-in-place bearings, and it sparked an idea. Why don't I just print the crankshaft and conrod in place? So I did, and it worked. Whee! It's pretty strong too. Oh fuck. I did have to sacrifice my finger in removing the supports on one of the test parts. Are we? Got him! But not to be deterred by a near fatal injury, I printed another one and it was good. My previous engine, I've used these metal bearings, which actually have quite a lot of friction. So I bought these ceramic bearings from China because apparently they have much less friction. This demonstration shows how much less friction is in these ceramic bearings compared to the metal bearings. Because they're not cheap and I'm broke, financially sensible, I only bought 2 of them, but I need 2 for the engine, so I can't break them. I made a few other changes too, such as removing the need for a gasket between the piston cylinder part and the bolt connection part by using the valve O-ring to seal the joint. The crankcase is no longer screwed together like this. Instead, I have left enough space so that the crankshaft and conrod can fit into the crankcase like this. And then the front cover is attached via a thread that's been built into the crankcase. This engine works in a similar way to my previous engines, with a couple of differences. The previous engine used an internal pushrod and used 2 2mm holes to exhaust the expanded air. The new engine's pushrod is outside the main body of the engine, as this gives me more space to increase the size of the parts, which hopefully means they will be stronger. Because as we all know, bigger is better. That's what she said! This pushrod mechanism may look a bit odd at first, because it is. The pushrod, as well as opening the inlet valve, also opens the exhaust valve, or it is the exhaust valve. Anyway, let's see how it works. The engine is started by spinning the flywheel. The flywheel is attached to the crankshaft and pushrod mechanism, so they also begin to rotate. The pushrod mechanism's rotation is offset from the crankshaft rotation. This means the piston and pushrod move up and down at different times and speeds. As you can see, the pushrod moves in and out of this hole. I'll explain why. Just before the piston reaches top dead center, the pushrod moves into the hole and through an O-ring, sealing the engine. The pushrod continues to move upward and opens the air inlet valve, introducing high pressure air into the cylinder. The high pressure air expands and forces the piston down the cylinder. Just before the piston reaches bottom dead center, the inlet valve is closed and the pushrod is pulled out of the hole and allows the low pressure air to escape. So this hole is now acting as the exhaust valve and remains open until the inlet air valve is to be opened again for the next cycle. The linear motion of the piston is converted to rotational motion at the crankshaft, which spins the flywheel. Some of the energy is stored by the flywheel and is used during the piston upstroke to open the air inlet valve on the next cycle. Now I think I've bored you enough with how the engine is supposed to work. Let's see if it actually works. This was super easy to print. I'm just so glad I didn't have to spend the last 3 days tweaking the slicer settings, the dimensions, just to get the thing to work. It works. Okay, 20 psi is almost sealed. Whoa. 20 psi. It snapped. The pushrod end snapped. Really, I should have saw this coming, but, you know, I'm an idiot. I've redesigned the pushrod so there's a slot for an insert. This is better than the previous one, as it allows me to still print the pushrod in the vertical orientation, so that it can be as circular as possible, but the insert can be printed in a different orientation, in a stronger orientation. So I think I made this pushrod slot too large, as the pushrod can just fall out. So I've decreased the tolerance slightly and printed another one. Let's try it again. Despite the leaks, I got it to work, but I had to keep pumping it up. After this test here, I quickly took the engine apart and cut this layer off, put it back together, and this seemed to solve the problem. Okay, let's try 30 psi. The engine spins at a pretty high RPM, which is cool and all, but it gulps through air faster than this guy inhales a bottle of water. So I've decided to decrease the diameter of the air inlet valve. I'm going with a 6mm ball bearing and a 4.5mm O-ring, which is half the diameter of the original O-ring I was using. So now I have to wait another 10 hours for both of these to print. Yay! That was finally printed and built. Let's see if it actually works. I think initially the friction between the O-ring and the pushrod was too high, but I just kept spinning the engine and eventually it seemed to wear in, and I got probably the best result so far, with a 22-second runtime starting at a pressure of 50 psi. I printed the part with 2mm walls, hoping this would be enough to stop air leaking out. But turns out it wasn't enough, and air broke through the part, which was why I could only get up to 50 psi. So next time, try and print it with 100% infill and see if this makes it airtight. But I'm going to leave that, along with a couple of other changes, for another video. Mainly because it's taken too long to get to this point already. Thanks for watching. If you liked the video, don't forget to give it a like. If you got any suggestions on how I could improve the engine, or what I could power with the engine, make sure to let me know in the comments. See you next time.